density? As many of you know, density is usually defined as its matter per unit volume. It is essentially measuring how tightly matter is compressed together. This density principle was discovered by Archimedes, a Greek scientist. In order for the bubbles to float in the air, it takes a ride on the gas that is slightly denser than the gas that is trapped inside of these bubbles, which is usually carbon dioxide. Like a bubble, a helium balloon also floats in the air because the helium inside the balloon is a lot denser than the air that is surrounding it.
Ever had your ears pop when you fly in an airplane? Or have them hurt when you go underwater? That's because air tries to escape through your ears with the air pressure that's outside your body is different than the air pressure that's inside your body. Your body tries to equalize the pressures, so they're the same, both inside and out. The air gets less dense the higher you go up. At sea level, the air is most dense. That means the particles in the air are colliding more often. As you get higher though, the air gets more dilute, meaning that the particles are having far less collisions. Pressure can be calculated in many different kinds of ways. Some of the units they use are ATM, kPa, or torr. The greater that number of units is, the more dense the air.
In the first Erlenmeyer flask, I'm putting hydrogen peroxide solution, which is slowly decomposing into liquid water and oxygen gas. In the second Erlenmeyer flask, I'm putting hydrogen peroxide, and I'll be adding a catalyst, which will speed up the reaction. The catalyst is potassium permanganate. This reaction is doing the exact same as this one, except it's going at a much quicker pace. Just like in the reaction I just did, in my car, platinum is the catalyst in my exhaust pipe. It prevents carbon monoxide from being released into the atmosphere. Instead, it releases carbon dioxide.
Here we have dry ice. Currently, right here, it's in a solid form. But in this Erlenmeyer flask right now, it's going through a transition called subliming, which means it's going from a transition from a solid to a gas, as opposed to depositing, which is the transition from a gas to a solid. Right now, it's going through an endothermic reaction, which means that the ice is absorbing the energy from the surrounding water. Here, we have a phase diagram. At this point right here, D, it's either a gas or a liquid, and at C, it's either a liquid or a solid. At these points, D, C, and A, these are all transition points, meaning that it's going through a phase change. But what we're really concerned about right now is E, which means it's going from a solid to a gas. That dry ice down there, it's subliming, meaning it's coming from a solid to a gas, which is really unusual in the world.
In our everyday lives, we see both acids and bases in our food. Acids produce H plus and H2O, they dissolve in water, conduct electric currents when they dissolve, taste sour, and they have a pH less than 7. Bases, on the other hand, produce OH minus in water, they taste bitter, feel slippery, and only some dissolve in water. Here we have some acidic fruits to make my famous fruit salad. After finishing my famous fruit salad, I wash out the bowl with a base. Remember, a base has a pH greater than 7 and creates OH minus in water.
Physical changes or reactions are when two or more chemical substances are mixed together, but their bonds can be broken. One example of a physical change is the dissociation of a solvent, like the salt or like the sugar right here, into the liquid it dissolves in, the solute, such as this water I have right here. When these two substances are being mixed, we're creating chemical bonds that we can later break if we want to. For example, if someone wanted to break the chemical bonds in salt water, they could let the H2O evaporate, leaving the salt behind. If I take a tablespoon of salt and a tablespoon of vinegar and put them in their respective glasses of water, they're both going to have the same concentration, but the substances are going to dissociate differently. A good example of dissociation is lemonade. Although there's plenty of sugar in the solution, you can't see any of it because it's all dissociated.
There are multiple types of radiation, examples being light, heat, and X-rays. There are two types of nuclear reactions, radiation reaction and fission and fusion reactions. During fission, one atom breaks apart into several other atoms. Nuclear power is very well known as a productive way to supply energy. We use the energy from fission, which we are able to control to make electricity. Unlike coal, we use 100 pounds of fuel a day to give electricity for a city of 1 million people. When using nuclear power, there is no air pollution. Although nuclear power has a lot of positives, there are still disadvantages. There is no place to put nuclear waste, therefore we are just storing our radioactive material on site. Also, there is fear of a nuclear explosion, which would create many problems, including the release of radiation into our atmosphere.
When one thinks of a chemical change, he or she usually thinks of something big and spontaneous or something that creates something big and spontaneous. A chemical change is when a new and completely different substance is created with different properties. A chemical change or reaction is a mixture of different substances in which the reactants are different from the products. In a chemical change or chemical reaction, it involves the moving of electrons which can create or destroy chemical bonds. Some of the examples of chemical changes and reactions would be like burning wood or the rusting of iron. One of the most common chemical reactions we have is with the baking soda and the vinegar. And when we mix these two together, we will get an extraordinary chemical reaction. Here it goes.
There are two major types of batteries, type 1 being dry cells and type 2 being wet cells. In a redox reaction, something must be oxidized and something must be reduced. For a redox reaction or battery to work, there must be a positive E cell. Car batteries use PbO2, and concentrated H2SO4, which is battery acid. Remember to never take your car battery apart.
Energy is one of those crazy hard things to describe. One of the ways people have tried to define it as something that can move from system to system while causing a phase change. And one of the ways that that energy can flow is heat. In a combustion reaction, like that one there, the products of the reaction are always CO2 and H2O. According to enthalpy, which is the total change related to heat, energy is released in an exothermic reaction and has a negative delta H. Gas is coming out through the sand right there. So if you bring a lighter to it, the gas will ignite, releasing energy as well as CO2 and H2O. Fire pits provide warmth in cold environments such as these. Right now, my toes are toasting. But you don't want to get too close to them though. It might get a little too hot,